Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. For some time I've been looking at sequence and series, and in this particular video we're going to look at how to find the sum of an arithmetic series. Let's get started. So the expression below represents a general arithmetic series where the terms are added. So this is like an arithmetic progression, but in this term we're using a plus and a plus and a plus. From the first video that we did on this, where we talked about the difference between sequence and series, it's clear that this is an arithmetic series because of the addition, right? Now, what do we know? We know that the first term is a, right? The next term after the first term will be a plus d, right? The next term after this will be adding the difference against this will be a plus 2d, on and on and on like that. And the last term, let's assume that the last term is L, right? So you agree with me that the one before it was L minus, or is L minus d, right? Because if I'm going forward, it's going to be increasing by d, but if I have any reason to go backward, I have to be subtracting d. This is a plus 2d. If I want to go backward, this will be a plus 2d minus d, so this will be minus d. So also if I'm going backward from L, this will be L minus d. We've already said it before, the a is the first term, the d is the common difference, and the L is the last term. In this particular formula, there is a relationship between the sum, the number of terms, the first term, and the last term, and I'm going to prove it for you to see. What we say, sum is equal to, so a plus the first term, second term will be a plus d, third term will be a plus 2d, right? And let's say the second to the last term will be L minus d, and the last term will be L, right? So we know addition is commutative. I don't know, we've not treated properties like that, commutative and all that, but what do I mean? 3 plus 2 is 5, right? If I do 2 plus 3 also is also 5. So either I do a plus b or b plus a, I'll still have the same answer. So also I can say sum is equal to, I'll start from the back, right? So this will be L plus L minus d, right? This will be plus L minus 2d, right? Plus, let me just say dot 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 plus, because I'm going from back to front. So the second to the last value would be a plus d, and this last value in the opposite direction will be a. Great. So this is equation 1, this is equation 2. If I want to add equation 1 plus 2, right, like I said before, this is a simultaneous equation. If you want to add to this thing, you just do this plus this is equal to this plus this plus this plus this plus this plus this plus this plus, and all to the end. So if I had these two guys, right, so sum plus sum is equal to 2 sum. A plus L is equal to a plus L, right? So this is what I get from the first guy, plus a plus d plus L minus d. You agree with me that this plus d and minus d, they will cancel out, right? You can also try that out. So that will be a plus L, right, plus a plus 2d plus L minus 2d. This minus 2d and plus 2d, they will cancel out. So I also have a plus L plus L minus d plus a plus d, minus d and plus d will cancel out. So I have L plus a. I can also say a plus L, right? So this is also plus dot dot dot, really, plus L plus a is also something as saying a plus L, right? So what do we see? We see that at the end of the day, when we are adding each of the terms, right, so if there are 5 terms here, you agree with me that we have 5 a plus L's, right? So that means that the 2 times the sum is equal to n number of a plus L, right? So I have n numbers of a plus L. N is from the fact that I could have, so if there were 5 terms here, I mean, I would just have 5 a plus L, and if it's the same thing, I could multiply it and say n times a plus L, instead of doing all of that, right? So at the end of the day, my sum is equal to, if I want to make the sum standalone, I can divide both sides by 2 and say a plus L divided by 2, right? So what you always see, okay, this is 2 sum divided by 2 is equal to n brackets a plus L divided by 2. So 2 will cancel 2, then sum will be equal to what? N open brackets a plus L all over 2. So this is one formula. So if I have the first term, the last term, the number of terms, I can find the sum of that sequence. But sometimes you might not be given the last term explicitly, but we know that from what's within the previous video that the last term in a sequence, let's say Tn, is equal to a plus what? N minus 1 D, right? We know this already, so I can substitute this and say, so this is equation, let's say this is equation 3 and this is equation 4. So substituting equation 4 in equation 3, so this Tn is also the same thing as saying last term. Don't be confused, this is also saying the L, which is the last term. So if I substitute, I could say sum is equal to n open brackets a plus all of these guys, right? A plus n minus 1 d, right? Then this will be divided by 2. Great. So the sum will now be equal to n open brackets a plus a is 2a plus n minus 1 d, so this will be n minus 1 d, right, divided by 2. So you can see that these are two ways of expressing the sum. So either it's n open brackets a plus l divided by 2, or n open bracket 2a plus n minus 1 d all over. So if you are given the first term and the last term, you can easily use this one. But if you are not given, and maybe you are given the first term, the number of terms, and the difference, you can use the second formula. So the choice depends on the particular question that is being asked. So we can see our sum is either half of n multiplied by a plus l, or half of n open bracket 2a plus n minus 1 d. Great. Let's see some examples that will further buttress the application of these formulas. This question says that we should find the sum of the first 100 positive integers. To find the sum of the first 100 positive integers, that will be 1, 2, 3 up till 100, right? Because the first positive integer is 1. So that means our a here will be 1, our l would be 100, and then n, if you count from 1 to 100, you have 100 value, so our n is the same thing as 100, right? So let's substitute. We know our sum formula is always write a formula, like I always say, is we can use n divided by 2 a plus l in this case here, right? So n is 100 divided by 2 multiplied by a is 1 plus l is 100, so that will be basically saying 100 times 101, right, divided by 2. So if we do 101 times 100, that will give us 10100 divided by 2. So if we divide this, we're going to have 50, right? So if we divide it by 2, you're going to have 50. Let's see if we're correct. Great. So that is 5050. The next question says that if the first term of an arithmetic progression is 3 and the common difference is 4, find the sum of the first 28 terms. Great. So in this question, we know that the a is 3, the d is 4, and the number of terms I said we should find is the first 28 terms. So we could say that the formula that we can use here, we don't have the last term, so we have to use the second formula, which is sum is equal to n divided by 2 open bracket 2a plus n minus 1 d, right? So our n here is 28, so 28 divided by 2. If I open this bracket, the 2a will be 2 times 3 plus the n here is 28, so that is 28 minus 1 multiplied by the d here is 4, right? So if I scroll down, 28 divided by 2 is 14. 14 times 2 times 3 is 6 plus 28 minus 1 is 27, right? So 27 times 4, this will be what will result from this. So 14 times, because of board mass, we're not going to do 6 plus 27 first, right? We have to do the multiplication first, so that will be 6 plus 27 times 4. If you do it in a calculator, that will give you 108. So this is 108, right? If you do 6 plus 27 first and you multiply by 4, that will be wrong. You must understand that multiplication has a higher precedence to addition. So this will be 14 times 6 plus 108. If you do that in a calculator, that will give you 114. And you multiply it by 14, this will give you 1596. Let's see if our answer is correct. Great, 1596. But one thing that you need to note is that you see that at this place here, I did 28 divided by 2 first. Some other time in the previous example that we did, right, I multiplied the top, right? I said 100 times 101 divided by 2, it is the same thing. I could have done 100 divided by 2, which is 50 times this guy, I would still have had the same answer, right? So the way you actually choose to do it is dependent on you. right? You could divide this 2, or you can multiply the top and then divide the value by 2. Any way you want to do it, you have the same answer. So the next question is saying that the entry salary of a teacher is 600,000. An increase of 24,000 is given at the end of each year. What will be the total amount the teacher will earn in 30 years? Great. So we know that the entry salary of the teacher is 600,000. That's the first salary the teacher will ever receive. So that will be our A. Our A will be 600,000. An increase of 24,000 is given at the end of each year. So every year is going to be increasing by 24,000. That will be our what? Our D. Great. So that is 24,000. So that says that what will be the total amount teacher will earn in 30 years? So when N is equal to what? 30, what will be the sum? This is really just the interpretation of the question. So we know that our formula for sum is N divided by 2, open brackets, 2A plus N minus 1D, right? Since we know this formula, let's substitute inside the formula. So our N is 30, so that is 30 divided by 2. In brackets, 2 times A is 2 times 600,000 plus our N is what? Our N is 30. So if I want to substitute, I'll say 30 minus 1, right, multiplied by our D is 24,000. So if I close the brackets, right, so this time I would let me divide this 30 divided by 2 first. That's 15. So 15 brackets, that's 15 times. Let me open the bracket. 2 times 600,000 is 1.2 million, right? Plus 30 minus 1, that's 29. 29 times what? 20. Let me put this very well. So times 24,000, right? Like as always, we don't do 1.2 million plus 29. We have to take care of the multiplication first because of board mass. So this 15 times. So this is 1.2 million plus 29 times 24,000. Let's see what that will give us. So I pressed on my calculator. I had 696,000, right? So let's simplify the brackets. That's 15 times 1896000. So if I multiply this by 15, what would this give me? This will give me 28440,000, which is basically 28,440,000. Let's see if our answer is correct. Great, that's correct. So 28,440,000 is the correct answer. Let's go to the next question. Now the next question is saying that we should find the sum of the multiples of 9 between 0 and 200. Now how can we know the first multiple of 9? Right, the first multiple of 9, if you do your multiplication table, that is 9 times 1 is the first multiple of 9. So the first multiple is 9, right? How can you know the last multiple of 9? Right, how can you know the last multiple of 9? Because not all the, see, it says find all the multiples. It not say you should find the sum of 0 to 200. It said find the multiples of 9. So we know the first is 9, second is 18, third is 27, 9 times 3. But how do we know the last? Do we keep on multiplying like that? No, there's a simple trick you can use. Right, so if I do 200, which is the last value, divided by 9, right, 200 divided by 9 will give me what? That will give me 22.22222. So I just need the first value. So 22. I just need the whole number part, right? The whole number part. So if I do 22 times 9, so 22 times 9 gave me 198, right? So this 22 times 9, this 198 is the last multiple of 9 inside this place. And you can try it out. You can see you can try it out with any other thing. Right, if I had 1 to 10, I wanted to find the, or let me say 1 to 20. Let me say 1 to 20. I wanted to find the last multiple of 7. Right, I'll just come and say 20 divided by 7. 20 divided by 7 is what? This is 2.85. I'm only interested in the whole number part, right? So I want that the last multiple of 7 will be 7 times 2, which is 14. And you can see that it's only 14. If I add another 7 again, that's 21. Is it within the bounds of 1 to 20? No, right? So that's a trick that you can use to know that. So I know that the last value here is going to be 198. I can use our formula, right? And if we also look at something, when we did 200 divided by 9, it gave us 22, right? It means that at the end of the day, it will be, this is 9 times 1, right? 9 times 2, 9 times 3, comma. So this is 9 times 22. So that means at the end of the day, we're going to have 22 terms inside here, 9 times 1 up to 9 times 22. So that means our n is going to be what? 22. Our a is 9, and then our last term is what? 198. Very neat. So we know our sum formula is n divided by 2, open brackets, a plus l, right? Let's substitute. Our n is 22, so that's 22 divided by 2 multiplied by the a is 9 plus the last value there is 198, right? So if we do that addition, right, that would be 22 times 9 plus 198. If you do that, right, that would be 207 divided by 2, right? So 22 times 207 divided by 2, this will give you 2277. Let's see if we are correct. Great, 2277. Now the next example is saying a couple stayed for 3 years before having their first child, then 2 years before their second, 2 years again before the third, and so on until the 6th child. If the husband was 28 years and the wife was 25 years when they had their first child, what is the sum of the ages of the couple a year before the last born? If they stayed 3 years before they married, so let's say this is the point of marriage, right? Let's say the 0th year was the year of marriage. So 3 years after was the first child. The next child was 2 years after, that is after 5 years. The other child was 2 years after the third, that is 7 years, up until the 6th child. So this is 9, 11, and 13, right? So the last child was 13 years after they married. So it says if the husband was 28 years and the wife was 25 years when they had the first child, what is the sum of the ages of the couple a year before the last born? Right, so that means at the point of marriage, I can say that the husband was 28 minus 3 years, right, which is 25 years, and the wife was 25 minus 3 years, which is what? 22 years. Why? Because it said the husband was 28 years and the wife was 25 when they had the first child. The first child was 3 years after they married. So at the point of marriage, they were 25 years and 22 years. So if I want to find the sum of the ages a year before the last born, a year before the last born was, so after 12 years, because the last born was born 13 years after, right? So that means a year before the last born was 12 years. So that means I have to add 12 years to the ages of the couples, right? So this man, the man was 25 plus 12 years, right? This is, it was 37 years, yes, and the wife was 22 plus 12 years, she was 34 years old, right? So if I had the sum, let me put this place as the woman. If I had the sum of the ages, 37 plus 34, that would give you what? 71. So that means that a year before the couple had the last born, which was 12 years after, the sum of their ages was 71. This question is more of logic than actual calculation, right? If you just know that if it took 3 years for them to have the first child, then that means that at the point of marriage they were 25 and 22 years. So 12 years after, by the time you add 12 to each of the ages, you know that total age is 71. Great, 71 years, so then we're correct. And the last question, it says that the first term and the last term of an AP are 79 and minus 5. If the sum is 814, find the number of terms in the AP and the common difference. Great, so what are we given in the question? Right, so if I put given here, we're told that the A is 79, the last term is minus 5, the sum is 814. We're told to find the N and we're told to find the D. Great. So we know that the sum equation is N divided by 2 multiplied by A plus L, right? I know the sum is 814. I don't know what the N is, so N divided by 2, open bracket. I know the A is 79 and the L is minus 5, so I've substituted that. So 814 is equal to N divided by 2, 79 minus 5, that gives you 74, right? So 814 is equal to 74 divided by 2, that will give you N times what? That's 37, right? So if I want to make N stand alone, I can divide both sides by 37. 37 here will cost 37. 814 divided by 37, you can take a calculator and try it out. When you do that, what did that give you? That gave me 22. So 37 here 1, 37 here 22, so our n is equal to 22 in this case. We know the n. Now the next thing is to find the common difference. How can I find the common difference? What can I use? So if I can also use the other sum formula too, and say sum is equal to n divided by 2 open bracket 2a plus n minus 1d, right? We thought that the sum is 814 is equal to the n. We already know the n to be 22, so 22 divided by 2 open bracket, our a is, what is our a? Our a is 79, so that is 2 times 79 plus 22 minus 1 multiplied by d. Great. So 814 is equal to 22 divided by 2 is 11. Open bracket, 2 times 79, take calculator and try it out. So that is 158 plus 22 minus 1, that is 21, right? 21 times d, that is 21d. Great. So I can divide both sides by 11 first to make this bracket stand alone. So if I divide this sides by 11, if I divide this by 11, 11 will cancel this 11. 814 divided by 11 will give me 74, is equal to 158 plus 21d. So if I carry the 158 to the side, that would be 74 minus 158 is equal to 21d, right? 74 minus 158, let's see that. If you do that on your calculator, that will give you minus 84 is equal to 21d, right? And if you divide both sides by 21, 21 will cancel 21, 21 here 1, 21 here 4, right? So that means our d is equal to minus 4, right? You can use another way to find the d, right? I just had to use the sum formula. So our n is 22, and then our d is minus 4. Let's see if we're correct. Great. So with this, we've actually come to the end of some of an arithmetic series. I encourage you to actually try these things yourself. Look for more questions in textbooks. So I recommend 2 textbooks basically. If you have New General Mathematics, very good textbook. If you see hidden facts in mathematics, there's a book, Hidden Facts in Mathematics. I highly recommend that book. Look for more questions to solve. If you have any question concerning what we've done or concerning the particular topic, please drop a comment. I would respond to every comment that I see, right? So in the next video, we'll be looking at geometric progression. See you there.